Okay, hello everyone. Once again, we are with you on ABP.NET conference, and we have Adora to talk about designing secure cloud native apps with .NET and Azure. And without further ado, I will leave the stage all to you, Adora. Thank you.
Thank you so much. Thank you so much. Hey, everyone. It's so amazing to be here. Thanks for joining my session. And also, I'm glad to know that you are attending this conference where we get to talk about .NET and Azure and every other thing in tech that is interesting. Today, I'm going to be talking about designing secure, cloud apps in this ecosystem. And I just want to talk about a few things before I even fully get right into it. So when we think about the cloud, there are a bunch of benefits that come from moving to the cloud and building these cloud native applications. You don't need to have software installed. Every resource that you need is available over the network. It's more cost effective depending on your use case. You get on-demand self-service. There's more redundancy, flexibility, reliability, scalability, and all those good things that come from leveraging cloud computing generally. But the truth is, with all of these newfound things, with all of this enjoyment, comes some form of responsibility, right? And there are many things that could come as a result of making mistakes, and there's some cloud security risks that could happen, right? The first one is human error. When we feel like everybody knows what they should be doing, but that's not really always the case, because as human beings we don't always know, right? When we feel like everybody knows that what they should be doing, and obviously as a result, a few things go wrong and things don't work out the way they should, because somebody is giving so much more permissions than they need to have to do a certain thing, and as a result of that some problems occur. Or when we don't set up the right parameters in place, and as a result of that it's easier to be hacked. Because the truth is, as we're building on the cloud, as we're innovating, as we're building out emerging technologies, there's AI, cloud companies are building AI into their cloud offerings. All these amazing things are happening. As companies are innovating, hackers are also innovating on new ways that they could hack you. So you want to make sure that you also don't fall for these malicious attacks. And the final one is compliance issues. Lawsuits are not cheap. You want to make sure that you're not at risk for any of all these kinds of things when you are doing business on the cloud generally. So today I'm just going to be talking about, a bunch of all these things. But before that, I'll just quickly want to introduce myself. My name is Adora and I'm a software engineer. I used to work at Microsoft, but I don't work at Microsoft anymore. But I've given this talk before, so I guess that's why you see what you see here. I'm a software engineer currently working at DB, used to work at Microsoft. I have a nonprofit called Nexaskill, and I'm the creator of Adora Hack, which is a blog and a YouTube channel that talks about software engineering, career growth, and productivity. I'm also the author of 3 books on cloud engineering for beginners, beginning Azure DevOps, and Confident Cloud. I'm on the advisory board for the VR AR Association in Nigeria, and you can find me on social media at Adora Nwodo. So now let's get right into the main gist of the day, right? When you are building an application, when you have to think of building an app and just sort of building a service that is global, that many people use, one thing I would always recommend is that before you start, you have a security checklist. And what the security checklist actually kind of does for you is that it helps you to analyze and understand how or what in your application needs to be secured. So you even want to be thinking, there's always a need for security, but you want to be thinking, what kind of security should I be looking at? What's in my application actually needs to be secured? How should we make this thing secured? And if you don't have this checklist, it's not going to be very easy to understand what needs to be done, especially if you're working in smaller businesses, right? Where the engineering team is also the platform team, the cloud team, as well as the security team. In larger organizations, sometimes there are dedicated security teams that give these compliance requirements to the engineering teams, and then the engineering teams work to make sure that the application meets this particular checklist. But this checklist, this stage, It's something that is very important in whatever application that you are building. And there are a bunch of few questions that you can ask yourself, or rather that the team can ask at the beginning of the design of the new feature that, can help with thinking of what this checklist should have. And one of them would be that, oh, will my application contain sensitive customer data, right? That's the first thing. And the next thing is around like, oh, where and how will my data be stored? If your application will contain sensitive customer data, then you want to think about how to store that data securely. You want to think about data encryption in transit. You want to think about data encryption at rest as well. So you want to make sure that the data is encrypted when it's, in the data store, right? And you also want to make sure that when that data is being transmitted when that payload is being transmitted, whether it's through HTTP or any other kind of protocol, you want to make sure that the data is also protected at that time. The next thing is, okay, where and how will my application's data be stored? Is it going to be stored in my personal data store? How do I make sure that hackers don't get access to that data store? Is it going to be stored in a public domain or in a data store that I don't necessarily manage? How do I make sure that I protect my users' data if the data is going to be stored in, that offline data store? So you start thinking of things like, okay, do I need to create backup for my users' data? If I'm creating backup for my users' data, I sort of need to let my user know that their data is going to be stored in multiple places, for the sake of compliance. How do we handle all of that? So this is something that you also want to think about, right? The next thing is, will this application be available over the internet or just internally? If it's going to be available internally, then there are fewer security things that you're going to have to deal with, as opposed to when it's available over the internet. Internally, you would still do a lot of things to make sure that your application is secure, right? But when it's available over the internet, it now means that you can't control who uses it, because when it's available internally, right, it's over an internal network, maybe through a school or through an office or something, and everybody is identifiable. People that are in that network are people that are authorized to be in that network, and things are a bit more controlled. But when it's publicly over the internet, it's a bit chaotic and it's a bit tricky. So you want to make sure that, okay, if my application will be available over the internet, I need to set guardrails in place. A bunch of things as well. How do I plan to verify my user's identity? Then you start thinking about, authorization, authentication. How do I plan my auth strategy? What are security ways around these things and stuff like that? The next question, what sensitive tasks will be performed in my application? These sensitive tasks would let you know what you need to be done to preserve the security of your application. And finally, does your application perform any risky software activities? For example, uploading is actually a risky software activity, but most people don't think about it like that, because if your application allows people to upload things, what if somebody uploads some kind of script or a malware, something that can get triggered and maybe steal information or act in ways that it should not ordinarily act in? So you want to make sure that you sanitize requests that come in. You want to make sure that when things are coming into your application, these are things that there's a way that you can control them, and things like that. And in all of this, right, this checklist that I just shared, I mean, there are many more questions that could be in this checklist. But if we look at the different questions in this checklist, we can split them into two problems. There's the data protection problem and there's the identity management problem. And these are the two things that we're going to be talking about today. The frameworks I'm going to be sharing with you are either data protection or identity management frameworks. And these three frameworks or patterns are the gatekeeper pattern, the federated identity pattern, and the valet key pattern. So now let's talk about the gatekeeper pattern, right? The gatekeeper pattern is part of the data protection scenario, like I said. And typically, applications functionality is exposed when they accept and process a client request. So if the system is compromised and a malicious user gains access, then all sensitive data will be exposed. You don't want to give everybody access to your endpoints. So what this gatekeeper does is that it sits in the middle of a public endpoint and a private endpoint, so that the public endpoint is what every client is exposed to, what every client has, what every client that is on the internet would call if they want to use your service. However, when they call that endpoint, they actually don't call your service. What they call is a gatekeeper. And what that gatekeeper does is to validate the request, to sanitize the request, and make sure that only valid requests can interact with the host. And at that point, once a request is getting to the host, it's a valid request, and then the host is what has secure access to service, to storage, to other things in the application. So this is an example of what a gatekeeper pattern looks like, where, like I said, there's a public endpoint that the client is exposed to. The client calls this public endpoint, and then once the public endpoint calls the gatekeeper, the client has a limited privilege mode. So there's a gatekeeper role assigned, and the gatekeeper can validate and sanitize the request. If the validation and, if the request is a valid request and is not maybe a sketchy request or a request that poses a security risk or something, then it can call that internal endpoint within the virtual network that the application has. So that's why sometimes you'd see that applications have their own internal virtual networks, and the services within those networks can communicate with each other, but a service outside of that network, like an external API request, cannot directly hit the service. The external API request can go through maybe like an API gateway or something like that. And that's how they get into the rest of the service. And this is for security reasons. So you are able to now call the internal endpoint. Once you now can call the internal endpoints because you've validated that the request is a valid request, then you can get into full privilege mode, do what needs to be done, and gain access like we saw before. The next pattern is the valet key pattern, and it's part of the identity management scenario, right? When you are building Azure applications or any cloud application at all, right, you want to make sure that people like have secure access to things, and you can securely control that access by issuing tokens to people that expire after a period of time, right? So this token can be any kind of, maybe like an STS token or some kind of token that they can use for authentication and authorization. And a good way to sort of like share this, a good example of this would be maybe when a client needs access to maybe a storage account, for example, because they are supposed to upload something to that storage account. So typically this happens in various steps. This particular valet key pattern, it happens in various steps. Typically, the first thing that would happen is that the user would request a resource, right, to the application. The application would then validate that request and generate a token and return that token to the user. Now, the user has access to that token and can use that token to now access the said resource that the user needs to do whatever needs to be done. And in that way, you can just make sure that you can control access. And like I said, the access is going to be given to whoever needs it for a specific period of time. So, and only giving for the permissions that you need it. So if you need maybe to request access to a storage account because you want to read files from that storage account, you would have read access for, let's say, like 20 minutes or something, right? And after 20 minutes, you can't use that token again because the token would be expired. You'd have to get another token. But even within the 20 minutes, that same token cannot give you access to rights to the storage account. So you can't upload things to that account, to that storage. You can only download things from the storage. So that way just keeps it. And this is an example code, right? That shows exactly what I'm saying. So we have a values controller that has a blob service client and a blob container. And this method just simply returns a limited access key that allows the caller to upload a file to a specific destination for a defined period of time. And in this code, the defined period of time is 10 minutes. So the method is called get shared access reference for upload, and we're passing in the blob name. So, we get the blob container client, and this code is, .NET code. We get the blob container client. We create the storage shared key credentials and sort of like build up the blob SaaS builder and passing the permissions that needs to be passed. So here we're saying that we want this blob container. This is the blob name, and that's the resource. We want access to start at this particular time, and we want access to expire 10 minutes after. So that way we know, right, that we're setting the access to 10 minutes in the code. So when somebody requests for this and they call this endpoint, whatever SaaS token we return to them is a SaaS token that is only going to be valid for 10 minutes. So now we've set the permissions, and all the SaaS permissions, all the blob permissions we're setting is the right permissions. We only want the blob to be able we've defined the policy where we only want this SaaS token to have rights permissions, right? And then we create the SaaS token, do whatever needs to be done, and then we can now return that SaaS token to whoever needs it and they can use it. So this SaaS token has rights permissions for this particular blob in this particular container, and it expires after 10 minutes. So you know this, and then you can use this to access the blob in the particular storage account that you want once you get this token, and after 10 minutes, the token expires, right? The third pattern that I want to talk about is the federated identity pattern, and it is under the identity management scenario as well. And this helps to separate user authentication from application source code and delegate authentication to an external provider, right? And because the truth is, these external providers, these people that run federated identity patterns, right? So let's say you're using Google SSO, you're using SSO like Rippling, you're using Microsoft Azure SSO for your application. These people have dealt with authentication problems longer than you have. So they have it figured out a lot more than you that is just trying to build a particular product, right? So if you can delegate authentication, right, delegate it. And this example here is a claims-based access control mechanism where the service is using some kind of identity provider or a security token service, which is called STS. And so the service is using the STS, and a user authenticates and requests an STS token. Once the user requests the token, right, the user gets the token from STS. And now once the user has that token, the user can present that STS token to the service and can access things. So for example, let's say I'm building a social media app, but I don't have time to integrate logging by myself. And I am using Azure. I'm using Microsoft rather. I'm using Microsoft authentication as my identity provider. Now, what happens is that a user authenticates to Microsoft authentication and they request a token. And if everything is well, their logging is valid, all of that, Microsoft will send a token back to them. And that user can now give me that token. And I'm going to be able to verify that. I'm going to verify the claims in that token and know the kinds of access I can give this user, the kind of user it is, what the user can do, what the user can't do. So it's claims-based. So I give you the token, and through that token, I read information about you and know what claims you have and what you can do within my service, essentially. And this is just like how it works, especially when you're trying to get like tokens across different tenants and enterprises, and how that works, right? So I've talked about like 3 ways that you can manage data protection or identity management. But then there are other ways to enforce security beyond these 3 architectural patterns, because these are just architectural patterns that I'm suggesting that people use when they build out their applications. But there are other things that you can do beyond these things, because the truth is those things are not even enough to enforce security in your application, right? So the first thing I want to sort of recommend is that you should use multi-factor authentication. This thing is so important. Whether you are an organization and you're trying to, recently, actually, AWS sent everybody an email that, like you have to set up multi-factor, I think 2 days ago or something like that. But it's just important to see, right? And everyone should enforce multi-factor authentication. I think it's something that is very important. And I mean, there are a bunch of different things. Passwords, which is, about what you know. Another kind of factor, which is about, which is maybe like your fingerprint on your eyes, which is like who you are. And OTPs, or sort of like tokens, or maybe phone call to send you validation numbers, which are like things you have. So these are like 3 different layers and 3 different factors. So at least you should have multiple of them for authentication when you're trying to build applications, because it just helps to make sure that you are not getting into issues, right? If that makes sense. The next thing is that you should consider implementing just-in-time access for your resources. JIT access, I think JIT access is very fantastic to users on your team, because everybody can't just have all the privileges all the time. A junior engineer can mistakenly do what they're not supposed to do, and they can make mistakes in your service, and it will be terrible if those mistakes were made in production. So you want to protect your resources, right? So JADE access is basically nobody has access. If anybody wants access, they request access for the resource they want access for the kinds of things they want to use it for, and for the time that they want to use it for. So let's say in Azure, right, we have a bunch of subscriptions, and somebody wants access to a particular subscription because they want to make changes in a deployment, or they want to do something like that. So maybe they want admin access, or they want contributor access or something. When they request that access, somebody has to manually approve. So there's a way to vet that, okay, this is the person requesting this access, this is what they want to use it for, and this is how long they're going to need it. So maybe JIT can go to like a particular portal or whatever, the person approves it, and after like maybe 30 minutes, 1 hour, 2 hours, depending on the rules that you set, it automatically revokes itself. And if the user still needs access at that time, if the engineer or whoever is on the team still needs access at that time, then they will go again and request another kind of access. But just a way to make it, to be sure that everybody doesn't have access all the time, because crazy things can definitely happen when people do. The next thing is that people should use stable authentication and authorization platforms. I think that this is something that is very important. When I was talking about SSO and, the federated identity, right? I spoke about using maybe Microsoft or Google or Rippling and, all these other ones. You want to use something that has a good reputation. Many businesses use it. It's a stable authentication platform, because it's better to build out your own than use a platform that is not stable and can create problems for you. Next thing is that you should also require re-authentication for some action. So if you want to do like financial transactions, for example, even if the person logs into the app, right before they send that money out, ask them a security question, or ask them to re-enter their PIN or something. So that way it's like, are you sure? Like, before you send this money out, I want to be sure that you are sure. Just a way to get people to re-authenticate themselves for some kinds of secure actions, because these things are important. The next thing is to reduce your attack surface, especially when you are in the multi-cloud scenario, right? If you have maybe cloud resources that you are not using, if you have a VM somewhere that you've deployed or initiated deployments for, but somehow that VM is not active, remove it. Because the truth is, once your attack surface is wider, you are giving attackers a larger surface area for them to try and hack into your system. So if they try maybe one VM and that doesn't work. They'll try the next VM, they'll try the next network, they'll try the next endpoint until they can get in. But if you reduce your attack surface, meaning that it's only the things that are active, like it's only the infrastructure that is active, the services that are actively maintained and actively being secured that, are online, it's going to be, obviously there are fewer things for them to get access to, and it's also going to be harder because those things that are there are things that you're actively maintaining. So if you can possibly reduce your attack surfaces, then go ahead and do that. This next one is not for proactive security, but more for reactive issues, security, and just like, regular problems in your application. You want to properly handle errors and handle exceptions. So if you have to react to things, if you have to debug, if you have to troubleshoot, if you have to do a root cause analysis, if you have to understand what's happening and why it's happening, you can see the problem and act accordingly. So you want to make sure that you properly handle errors and exceptions that you need to handle, right? And log what needs to be logged, right? You also want to make sure that you monitor your service and you trigger alerts about different kinds of issues, security issues, performance issues, and things like that. It's also important to encrypt sensitive data, data in transit, as well as data at rest, implementing fail-safe measures and doing some kind of threat modeling as well. So yeah, so for threat modeling, there are many threat modeling frameworks, right? But I think one of the popular ones that Microsoft even uses is the Stride threat modeling framework, which I think is something that you can check out. And threat modeling is pretty much just a way for you to anticipate potential attacks potential threats that your system could have, sort of like model those threats, being proactive about security before you build out the application, model those threats, understand the threats your system could have, model those threats, and provide solutions to those threats in the context of your application, even before you start building it, right? So if, for example, let me use the D in Stride. If denial of service attacks is going to be a problem in your application, maybe you might want to introduce a rate limiter in your infrastructure from early on, so that after a particular IP address makes a particular number of calls to your application, that IP is now going to be denied calls if what they were trying to do was overwhelm your system, right? If elevation of privilege is going to be a problem, then maybe you want to have authentication and authorization set up properly. If tampering is going to be your problem, then maybe you want to have like the correct certificates set up, your HTTPS and your TLS certificates, your SSL certificates and things like that. So you just want to make sure you want to sort of like be proactive in looking at the security issues that you have and then solving those problems even before they become problems and even sometimes before you start building. Next thing is to use secure open source libraries. And I'm saying this because open source is very big right now. There are a lot of open source tools. Many of the developer tools right now that we use in our day-to-day are open source. Some of them have like cloud offerings, and those cloud offerings are what enterprise companies typically use. But regardless, those cloud offerings are built on top of the open source technologies anyway. So you want to make sure that you are using secure open source libraries or open source offerings. If you are using libraries a lot, you want to make sure that you update service dependencies so that there are no vulnerabilities that can create issues for you. And you want to make sure that you are not hard coding secrets or passwords or all these kinds of things. One mistake that junior engineers make, and I think this is why it's also very important to have security training for your engineers, and also just have like linters or code search algorithms that catch all these security issues even before people merge things to production. Like a common example would be that somebody is maybe working on a project on a PR and they had code a password, right? And at that time, when they had coded it, they were still maybe testing on their branch, and to them, they didn't think it was a big deal. And when they were done and it was time for them to open the PR, they did it the right way. They referenced it from a secrets manager. They did all of that. But they didn't change the password. They didn't roll the password or update it to get a new password, so that that invalid password that they checked in that is still in the commit history is, no longer a real password for the app. They left it there. And like, weeks later, there's maybe a breach somewhere and people are wondering what's happening. It's those very little things, right? Even if they didn't check it anymore into production, or so they thought, but that password is still somewhere in the commit history. And there are some funny bots that are helping attackers scan through code bases and find the sensitive things and use them against other against organizations and engineering teams and things like that. So you want to make sure that people are properly trained to understand the different kinds of ways that they can be hacked, right? And just so that they can act accordingly. These are some of the links on security, building cloud native security, doing security better in the context of Microsoft and Azure resources, and even generally on the cloud. So you can check out these links, and I hope that they're useful for you. I don't know if there's any questions right now, but thank you so much for watching this. I hope that you learned something new, and I hope you enjoy, every other talk from every other speaker.
Thank you so much, Adora. We just have one question, and David is asking if the presentation is available somewhere. Can we share the presentation?
The
with the
presentation is
attendees?
available. I could send a link. I could also tweet it if that's okay. I know that it's available on my speaker deck. So if you go to speakerdeck.com/Adora Nwodo, I've actually posted this presentation before. So you can find it there on the internet and you'll be able to have access to it.
All right, thank you so much. I will do that and be sure to share that in the chat section and pin it for the attendees who are wondering. Thank you so much for today's session. It was very insightful, and I'm sure all the attendees learned something from you.
Thank you so much.
Thank you so much for being with us today. Okay, well, we'll say our goodbyes and we will have a main break now, and then we will meet you in 1 hour. All right. Have a great rest of your day.
Okay, bye everyone.